Welcome to the cBioPortal tutorial series brought to you by the Genomic Education team at the Jackson Laboratory. This video describes how to calculate the median age of diagnosis within a study on the cBioPortal. The median is a statistical value representing the midpoint of a dataset. In this instance, if you lined up the diagnosis ages of all the patients in a study from youngest to oldest, the median is the age that falls right in the middle. In this example, we have 11 ages lined up from smallest to largest. If we count 5 from either end, we get to the middle value, which is 57. This indicates that our median for this dataset is 57 years old. It's a little more complicated when there are an even number of samples in a dataset. In this next example, there are 12 ages arranged from lowest to highest. If we count 6 from either end, we can zoom in on the middle ages of 52 and 57. Because there is not one value that is in the middle, to calculate the median, we need to take the average of these two middle values. To do this, we would add 57 plus 52 and divide by 2. And then we would reach a value of 54.5, which is the median for this dataset. Now let's look at a study on the cBioPortal. Because the datasets on this database often have hundreds or even thousands of values, we can't easily line up all the ages of the patients within a study. Thankfully, there's a tool on the cBioPortal that will help us calculate the median age value. To do this, find the diagnosis age histogram on the summary page of the study. Like on this pancreatic cancer study, we scroll down to diagnosis age histogram here. Hover over the diagnosis age box until a hamburger menu appears in the right corner. Hovering over this menu reveals a few options. Select Compare Groups and then select Median. Upon selecting Median, a new browser window will load with an image of red and blue squares. Focus only on the two squares on the right under Patients Overlap. Each square is defined with an age range indicated on the key on the right. Looking a little closer at the red and blue squares on the right, we can see that this group of patients in this study has been divided into two groups. The red square represents the older ages from 67 to 86, and the blue square represents the younger ages, or 29 to 66. Because there are an odd number of patients in this study, 109 in total, one of the groups has more patients than the other. You can see that the red group has 54 members and the blue group only has 53. Therefore, the midpoint value is the youngest person in the older group of patients. If you look at the key on the right, this group has patients as old as 86 and as young as 67. Therefore, the median or the midpoint age is 67. Now let's look at a few examples for when there are an even number of patients within a study. In this first example, there are 184 patients in the study, so each group now has 92 members. Looking at the key, you can see that the youngest age of the older group in red is 65, and the oldest age of the younger group in blue is also 65. Therefore, the median age is 65, since the midpoint would be calculated from an average of these values. In this case, the values were the same, so we didn't actually calculate an average. In this next example, with an even number of patients in the study, again we see the groups have the same number of patients, with 5 in the red group and 5 in the blue group. But this time, the youngest age of the oldest group is 51, and the oldest age of the youngest group is 49, and they are not the same value. Therefore, to calculate the median, we need to take an average of these two values. To do this, we would add the two values together and divide by 2, which in this case, 51 plus 49 is 100 divided by 2 equals 50, and therefore the median for this example is age 50. Thank you for your attention. To learn more about the cBioPortal and its features, continue to watch videos in this tutorial series. For other resources from JAX Genomic Education, find us on our website.